Hey everybody, I'd like to show you how to use Desmos to find the limit of a function at a certain value, as x goes to a certain value, And I just put in a sample function here for us to explore. Now typically Desmos is a graphical tool, so we would focus on the graphs generally, and we're going to find the limit by looking at the graph. But the bigger emphasis I wanted to show you is how can we find the limit of this function numerically? So we're going to use something called the table feature in Desmos to look at the numerical value in a table and then deduce what the limit is. But before we begin, let's play around with the graph. Now, based on the graph, we got a rational function over here. If x equals 2, we're going to be dividing by 0. And I want to show you a peculiar thing in the graph. It looks smooth and continuous here, but if we go close to 2, really slow, steadily past it, right there, when x is 2, the function value is undefined. So there is literally a hole in this graph at x equals 2. Let's calculate the limit of this function by just looking at the graph. And so our goal here is to take some x values, and we're going to take our x values and move closer to the number 2. And as we do, we're going to generate points, and the points are going to have new y values, and we're going to explore the outcome of those y's. So here's my first x number. I'm going to keep moving x closer and closer to 2. X is 0.7, y is 2. Now watch the y behavior. Now x is 1.13, and the y is gone up higher to 3. Now x is about 1.5, and the y is 5.25. So when we look at the limit, we're trying to see, as x gets closer and closer to 2, what does y get closer and closer to? And it seems to keep growing. 5.35, 5.76. 6.02, 6.1, 6.4, 6.8, 7.26. Now we're almost next to 2. Our x number is 1.9 and our y number is 7.5 basically. And we're almost next to 2. We're very, very close to 2. X equals 1.994 and the y number is 7.96. Now, if we collected all that data of the y numbers, it appears like the y numbers are headed to 8. Even though we can't get any closer, we can get 7.96, but it looks like these values are headed to the number 8. And that's kind of implied here from there's points on the graph, and they're headed over to that number 8. So as these x's go to 2, these y numbers keep going up, 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 and they're eventually going to the number 8. So graphically, we could say the limit equals 8. That's from the graphical approach. Okay, now let's imagine we don't want to make a graph, we don't have a graph, we have a problem that we're solving, and the directions in the problem say solve it numerically. Then you can't do the graph here. So how would we solve it numerically? If we didn't have our graphing calculator, we could use Desmos. Let's clear all that off. So imagine there's no graph to look at. So what we need is a table of values. And over here is the plus sign. And with this plus sign, you can add certain tools to work with in Desmos. And the one we're interested in is tables. So I'm going to add a table here. Now, I want you to notice line 4. It has x, a function of x, and these x inputs. And line number 4 is what made the graph. So you have x in, f of x is your y out. And so that's an x that can change and you can graph. Now on number 5, I've got the table. Notice it says x1. X sub 1 is referring to a very specific x number. And so it's also got an output, y1. And you could type in a function here for y1. you could copy and paste this in here for your output. But what I'm going to do, just for another way to do this, is I'm going to type in f of x. Okay, now notice the warning here. It's telling us our variables are kind of messed up here because I have an input that's a specific x sub 1, and I have a function that has a generic x here. So I need to tell the function, don't use a generic x, use that specific x1. And you can just type in the 1 after the x, and it understands that you're talking about x sub 1. Okay, now we want x to get really close to 2. So we can just put in data into the table. We might start at 1, enter, skip to 1.5, enter, 2. Now I tried to predict where I was going next, and I don't want to go to 2 yet, but I want to get really close to 2. So maybe I'm going to go 1.9, 1.99, 1.999. I don't know if we want to see it more, 1.9999. And now we have information when we look at the y values. As x's get closer to 2, the y numbers get very, very close to 8. Now if we put in 2, we saw before it's undefined, there's no value there. And we could look at the limit on the other side by going just a little past 2.0001. Now let's if we worked backwards, we'd have, I'm going to reverse all of this, 2.001. Let's say we got 2.1 and 2.5. All right, so if we were to look at the table, we could make some conclusions here about the limit. Here, my x's are x is approaching 2 from the right. So we're coming at the number 2 on this side. And on this side, let's change the color real quick here. If we approach 2 from this side, that would be these numbers here. They are approaching 2. X is going to 2 from the left side. But in both cases, what we see is, and here, on the left, we're getting 7.999. On the right, we're getting 8.006. So we can make a very good estimate and say it looks like this limit is equal to 8. So we found the limit there. So there you've got it. You've got 2 ways to find a limit, graphically and numerically. So if you need to use, if you don't have your graphing calculator, you can use the table feature in Desmos. Good luck with this. Hope that helped. Study hard.